I want to run through some of the homework problems from last night, because I know I didn't have time to talk about them in class. We'll do even a little bit more practice with this, because I know it takes a while. But number 7, which turns into number 33, when they actually ask you to graph it, y equals 1/2 sine 2x. So what do those do? The 1/2 squishes by a factor of 1/2 in the y variable. So the way I like to think about it is, if you take that 1/2 out, you're about to graph sine 2x. You're about to report the y variable, and then at the last minute you change that y variable. So it's because it's on the outside, it's the last thing you do, it's going to change as the y variable. And then this guy, it seems like it might do the opposite, because it's a number bigger than 1. Because it's attached to x, though, it works opposite from what you might expect. That actually squishes, again, by 1/2 in x. Because it's attached to the x, that's going to work horizontally, but it actually squishes it. And so that's what you really have to remember, is that these guys, when they're attached to x, they work backwards from what usually people's intuition is, that that's a bigger number actually squishes it. And we'll be able to double check that in a minute. Now, the other main thing about this is that if we want to graph this efficiently, we only have to figure out where our landmark points go. So I'm going to go ahead and graph the standard graph of sine, one period, with their landmark points. But you don't actually have to do that if you have that available to you, if you're looking at that in your notes or something. So here's the period of sine is 2 pi, and the max is 1, and the min is -1. And one thing that's good is you start with one period and then divide it up into quarters. And so that's going to be pi over 2, 3 pi over 2. And it goes from middle to high to middle to low to middle. And you got to remember that, definitely. Okay. All we have to do is we have to do these transformations on those points, those 5 points, and to get our new graph. And then we just connect the dots. So let's pick this point, for example. What does it mean to squish in the y direction, y variable? It just means multiply it by 1/2, which makes sense, because that's what this does algebraically. It multiplies by 1/2. And so that's going to go, it's going to have y coordinate. Well, let me put the coordinates in. Pi over 2 comma 1, to be really clear. That's going to change to 1/2 in the y coordinate. This is going to squish it as well, so it's going to change to pi over 4 1/2. And I'm going to plot those in a second, but I'm going to give you a little hint about how to do it even more efficiently in a second. This guy, the 0 isn't going to change in the y variable, but I'm going to change that to pi over 2, 0. This guy is going to change to 3 pi over 4 minus 1/2, because it's at 3 pi over 2 comma -1. I'm just taking half of all those. And this guy is going to go to pi comma 0. So I need to just graph those 5 points and then connect the dots, and then that'll be one full period. And then what you really want 2, but that's easier once you've got one period. So what I usually do is I make sure I look at the start and end of the period first. Oh yeah, 0, 0, because there's no shifting involved, that's just going to stay where it is. So that's going to stay right here at 0, 0. 2 pi, that's going to get squeezed down to pi comma 0. That point is becoming pi comma 0 right here. And the reason I look at the ends first is then it's easier to see how the others slot in, because the others are always going to be, the middle here is going to be exactly halfway in between. Pi over 2, oh yeah, that makes sense. And then the pi over 4 and the 3 pi over 4 are just going to be the quarters of that. And so this pattern is going to get squeezed down. Now it's going to go only up to 1/2 and minus 1/2. And so here's pi over 4 comma 1/2. Here's pi over 2 comma 0. 3 pi over 4 comma minus 1/2, and pi comma 0. And so we can see it's been shrunk both in the x and the y directions. If you're having trouble visualizing shrinking the whole graph, you want to just concentrate on the landmark points and think shrinking just means multiplying by a number smaller than 1. Stretching means multiplying by a number bigger than 1. You just need to know those numbers that you're stretching or shrinking by. Now, okay, so there's one period. Now I just look at the period. It's pi now. Remember, the shorthand for that is period is 2 pi over b. Here it's 2 pi over 2, which is pi. And that's confirmed by what I was doing explicitly here. 0 to pi gets you 1 full cycle. And so we're just going to add pi to all those guys. So that's going to go out to 2 pi. And going to look like this. Okay, so there's 2 full periods of that thing. Okay, let's see if I can fit in under the 10-minute limit, if I can fit in the next one, which is number 11 turning into number 37. And that's y equals cosine 2 pi x minus 1. Now, note the parentheses are here. If there were parentheses around the whole 2 pi x minus 1, then you'd be shifting in x. This is really shifting in, no shifting in x, but shifting in y. So that's going to squeeze in x, and this is a plus or minus, not a times, so that's going to shift down in y. And the period, let's just calculate that first. Ooh, 2 pi over 2 pi is 1. That's interesting. So when I lay out the graph, I'm going to need room for 2 full periods, so I'm going to put 1 here and 2 here. Okay, so now let me just quickly sketch the cosine here. So cosine looks like this. It starts out high. Okay. And so we just need to know it goes high, middle, low, middle, high. Starts out high and goes down. So the quick way to do this is once you've got the period, if you can nail down the start and end of the cycle, the other 3 points you can get by just halving and quartering. So I need to know where the start of the cycle is going to go to. That was 0, 1. Now this squeeze in x is going to multiply this x variable by something. It's going to multiply all your x coordinates by 1 over 2 pi, because it's a squeeze. Well, that doesn't change that 0. And it doesn't change the 1 yet. But, this is going to be a shift down in the y variable. So I'm not changing the x coordinate, but I'm shifting this guy down. So that goes here. Now, let's go to the end of the cycle. That's 2 pi. Now, when I squeeze that guy by a factor of 2 pi, that's going to become my 1, which is the period. Makes sense. And again, the 1 for the y variable is going to shift down by 1. So the max is now shifted down. If this guy is going between minus 1 and 1, that's its limits, its maximum and minimum. This guy's going to go between 0 and minus 2. So I can actually put that in right here. I'm not using quite the same scale. Oops, let's say that's minus 2. Okay, I'm not using the same scale on x and y. So there's my start and end of the cycle. Those are the 2 high points. Now, I don't even have to do a whole lot of algebra here. At 1/2, it's down at its minimum. Okay, that's going to be that minus 1 point shifted down by 1, and so it's going to be here. Oops, sorry, was not paying attention. That's at 1/2. There we go. Okay, and then the center line. Let me dot that in as well with maybe a different kind of dots. I always like to dot the center line. The center line about which it's oscillating up and down, it was the x-axis. That's been shifted down by 1 unit, and that's here at minus 1. So a quarter of the way through and 3/4 of the way through the cycle is going to be going through the center line. And now we're ready to do that. And then it's just going to do the same thing again. And I'd want to put this in. This is like 3/2, 5/4, 7/4, and 2. And it wasn't great for the second period. So there, a recap. Know where your points are for the standard graph. In this case, it's cosine, because this is what I'm doing is a modified cosine. Especially the start and end. Know your period. Then block out the start and end of the period, and then just do quarters, and then the rest of it is almost going to follow along automatically. You need to know your max and your min, and so we had to know that shift down, certainly. But once you got the start and the end, it's not too bad. I'll do a couple more involved examples in a second video.